Thank you very much for the invitation. It's a pleasure being here. I should say I'm also involved with the geography department, so I'm kind of a chemist working interdisciplinary topics, and the research I'm going to show, it's actually the result of an interdisciplinary study. It's only possible, basically, this research, thanks to the collaboration with myself as a kind of geochemist of some sort, with Martí Horta, who's a biologist by training, but who did his thesis on this area, in topics in this area, and on social conflicts, and also remote sensing. And Pedro Mayor, who's professor titular in this university in the veterinary department, who's worked with, who basically works in tropical fauna in this area of the world, and spends 6 months a year in the Amazon, basically, every year. And the students that I'm going to show the results from, they also have a range of trainings, from an engineer to a remote sensing environmental scientist, not an environmental scientist. Yeah, well, actually there are 3 environmental scientists here, I should say. So it's an interdisciplinary topic. The work also, I'm starting with the acknowledgements. This research was done thanks as well to the collaboration with indigenous communities in the area that I'm going to kind of describe briefly or shortly. And the aim, one of the underlying aims of this research was to provide data, hard data, to citizens. We'll talk about citizen science sometimes. So the idea was to provide hard data to individuals that see their well-being or lifestyle threatened or change, or undergoing some pressures to change. And they wanted data. And they got in contact with scientists in Europe, at ICTA, where I'm working at present. And they eventually contacted us, and we ended up, in a way, working with them or for them. Okay, so it's a kind of a relatively complex project. I said these are the guys that I would have only been able to do this research thanks to them. So what I'm going to show is actually our research, right? I want to emphasize that. We get on very well together, partly thanks to the fact that we acknowledge that by working with Martí and Pedro, we make a team that we can come up with this type of research, and results and so on, which now we are beginning to publish. We work in the Amazon. Very pretty, lovely place, in an area which is extremely remote, as we'll see. You need to spend 3 days going upstream in the rivers, in the headwaters of the Amazon, to get to the main area of study. There are still uncontacted peoples up there, a lot of red-listed species. By any standard, for any European like us, is an extremely remote place. More remote than many places in the Arctic that we can relatively fly and get a road. There are no roads here. The closest city from where we started this trip upstream for 3 days is Iquitos, 1 million people, and has no roads. So in order to get to Iquitos, which is relatively large, you can only go by plane or by boat along the Amazon. So by any standards, for most people in the world, it's a very remote place. But it's not a remote place for oil companies. Oil companies basically have a technology which is probably beyond the imagination of most people in the planet, and they can go anywhere in the planet and get oil, extract resources, and probably other type of companies that try to get some kind of resource from the planet, from the Earth. And as it happens, it was new for me, I don't know if it's new for you, but many of the tropical rainforests are lying on top of oil reserves. Many of them still untapped oil reserves. Okay, there was this paper in Science some years ago that basically was quantifying that 30% of the world's rainforest overlap fossil fuel reserves. And in the Amazon is the highest percentage. Okay? So of course, countries in the region many of them have developing economies, they want to use, make something out of these reserves. This paper was highlighting the oil reserves in the Amazon, but also in Indonesia. So it's what I'm going to show. I think it's also showcases, or it's kind of can be extrapolated to probably other areas of the world in which scientists have not yet gone to understand what's going on, or that local citizens there, indigenous populations there, have not yet been able to explain the situation outside their area or their country. So we work in northwest Peru, and the first time that Martí came to see me, and we took Google Earth, and we started zooming into the area, and it all looks to someone who's not an expert in this area, it looks all very green. There's deforestation in some places, but we started zooming in this area, and it looks very much like a solid, continuous rainforest. But in fact, oil companies for quite a few decades, in the area probably in the 1930s started, oil companies exploiting oil in this region, in Ecuador, in Peru, in Brazil. And they basically, with their resources, they just have traveled to the area and been extracting oil for decades. There was an oil boom in the 1970s, where at the time 70% of the oil production in Peru came from this region. This block, we call it, the whole region is basically divided in different oil blocks, as they call it. We're going to be focusing on this block, which is very close to the Ecuadorian border, Peru-Ecuadorian border. Okay. And still recently, 40%, 39% of the Peruvian national production comes from this area. This area, this would be the Loreto region. Just to give you an idea of the size, it's probably kind of the size of Spain. Okay, so this is relatively not small, but it's not. It's only a fraction of what the whole area of Peru is, and that's. We'll see at the end why this is important, just to have this idea of size versus the production and what comes out from this area. So you zoom in into this area with Google Earth, and you see some of the major rivers in the area. Okay, these are the headwaters of the Amazon. They all go down to the Corrientes, the Pastaza, the Tigre rivers. They go down to the Marañón River, which then goes into the Amazon. But you can also see in between the rivers, the main rivers, some kind of lines, some wiggles. And these are basically the roads the oil companies have built over the years, and some of the infrastructure like pipes, okay, to carry oil from one place to the other, which is basically crisscrossing the jungle, the rainforest. This would give you an idea of this area of the oil block, which would be marked by this white line. The black are the pipelines. Okay, and then you can see as well indigenous settlements in green dots. So clearly this is not a remote area for many people living in this region. And they have basically as well, the Peruvian government has granted them ownership of the land, or recognizes the rights to the land rather. Okay, they have titled and used indigenous land. So basically this oil block overlaps with some indigenous territories. This would be zooming into the Pastaza central oil facility like Andoas, and the oil companies both built, I'm talking about plural oil companies because there'd be more than one oil company working in this area, and they built this airport. And the indigenous settlements, the original indigenous settlements are along the shore of the river, and then the rest is basically oil extraction facilities. There will be different oil wells, that would be the roads. Okay, and you can see as well here at the end of the airport, okay, this line. This is the Pastaza River, so that's a relatively sizable river. So at the end of the airstrip or the airport, you can see this line. I don't know if you can see that, Maggie, with this is the pipeline, the oleoduct that takes the oil that is extracted from this region to the coastline. It crosses the Andes, and then it goes into Peruvian coast, where then they export it elsewhere, if they need to. So there's quite a sizable infrastructure in the area, which for me, when I started getting involved in this project, I didn't have a clue, and I've been working on the oil petroleum contamination for quite a few years, in fact, and usually, when we think about oil pollution, think about the ocean or oil spills, but never really thought that there could be any conflict or any issues about oil in the Amazon. I don't know if it's just me, but I think it's quite general feeling. As I said, oil companies have been working in the area, and that's how kind of at ICTA we end up being involved in these things, mainly through, or thanks to, or due to Joan Martínez Alier, one of the leading experts on ecological economics, because these activities from the oil industry in the area have led to considerable social conflicts. There have been dead people, there have been armed confrontations between the indigenous populations in the area and armed forces from the government or paid by the oil companies. There are people in exile, indigenous leaders. Of course, then there was the involvement of lawyers in Peru that then got in contact with people elsewhere asking for help in the same way the Catalans we are doing now with our own conflicts. This has happened here as well, but related to the oil industry. And they've been, it would be the Achuar, Quechua, Quichua, Cucama, Cucomilan, Urarina indigenous people. And they've been complaining that they live out of the land, they have a subsistence economy, and that the watercourses, the rivers, were getting polluted with the kind of stuff that smell funny. But they said that they were getting ill. They were kind of reporting some sort of effects, basically, that what's going on here with the oil extraction activities was not innocuous to them, but it was having really negative effects, with their own health and their rights to move around the area. So eventually the government got involved, and they did analysis, and they did determine that there was, very high levels of hydrocarbons, chromium, lead, mercury, barium, and chlorine in soils, river, waters, and sediments above the Peruvian maximum permissible limits, and that people in the area, including children, had very high levels, basically all of them, of lead and cadmium in their blood, well above the permissible limits. So then starts the quarrel about where is this coming from, who's responsible for this, right? It seems obvious to them that is the oil companies, but it has to be demonstrated. So what we've been trying to do is basically get data to see who's responsible for the presence of this oil. Seems very obvious, right? It has to be the oil companies, it's the oil companies. But other things more subtle, maybe not, like metals in blood, where are they coming from? So yeah, I mean, and these images are very impactant, but are very, they clearly dramatic if you want, but are they really representative of the whole area? Are we talking relatively sizable area? Is this very localized? It's widespread. Okay. The oil companies have been forced to remediate some of these spills. This is a very aggressive environment. You see some of the pipes, they are just iron pipes, so they get corroded very easily in this high temperature, high humidity environment. They get corroded. So it looks, the infrastructure there needs a lot of maintenance. So, I've seen things like that. I mean, this is unacceptable in Europe, right? So that's quite widespread down there. Out of mind, out of sight. Out of sight, out of mind. And this is an example of a remediation approach. So basically, they remove any vegetation, anything that is living next to this case would be a river stream, a small stream. Rivers there are massive, right? Some of the most The largest rivers in the world are there, but this is basically a very small stream, and they just basically scrub everything, put it in some kind of containers, and leave it there. So, and this is one of the key papers, and they have an ambivalent relationship with scientists, because when scientists have gone to the area, they have not always helped them, they say. Because, scientists, we go there, we analyze things, and then we try to interpret them. And this study has had massive impact because they said that indigenous communities in the Amazon basin, have very high levels of lead in the blood. And in one of the conclusions of the paper said, well, lead is not in oil, right? Has anybody heard about lead in oil? There's no lead in oil. So the first time I saw this paper, I talked to Miguel San Sebastian, who works in Sweden, and basically said elevated levels of lead in the oil non-exposed community pointed out at other sources yet clarified. So they were arguing that the oil industry is not responsible for everything that happens there, right? For some reason, these guys, the people living there, had high blood levels in the high blood levels, but not necessarily has to be the oil industry. So this is also one of the key issues we wanted to find out. Now, I don't know if another thing that I learned working with in this project with Martí is about produced water. Does anybody know about produced water in oil? So I'm a geochemist. I've been working since I finished my degree in 1990 on oil and petroleum contamination, and I didn't know what was produced water. So I was quite ashamed myself, because produced water is one of the main problems the oil companies have worldwide. It's one of the products of their activities that is causing them more problems, and it's more costly nowadays, because most of what is extracted from an oil well is water. It's not oil. It's not the black liquid that we see and that we use distilled in our cars or whatever. In fact, what is extracted mainly from an oil well is water. Is this produced water, has different names, but produced water is the name we're going to use here, which is basically intrinsic to any oil formation deposit, any reservoir. Okay? Along with oil and gas, there is water. Now, this water has been underground in contact with the oil and the environment and the rocks. It comes from basically the formation process of oil. Oil is the remains of basically phytoplankton in the oceans, so it's salt water. But as this water has been underground, has become extremely enriched, and I'm emphasizing extremely enriched in salt. They're basically brines, salmorras, and also metals and heavy metals, all sorts of metals, hence lead as well is one of the most abundant metals in produced water. And of course, it gets mixed up with other products that the oil companies use to improve the extraction efficiency of oil from the well. So there's also a suspended drilling products additive they used, as well as hydrocarbons as well that are dissolved in the oil. So in pollution terms, it's extremely contaminant product. And I don't know, but still, if you look at the literature on pollution, environmental pollution, you will find very, very few studies dealing with produced water pollution. And it is the main product of oil companies worldwide. How much, what I mean the main product? The average estimate worldwide of produced water is 2 to 1 or 3 to 1. So when an oil well is opened or is drilled, for each barrel of oil, there are 2 to 3 barrels of water. Okay? Now, as the well gets older, the proportion of water to oil increases. So, in the US, many fields are very mature, and the average proportion of the US water to oil is to 1 to 8 to 1. But in oil wells, it can go down to up to 50 to 1. So for each barrel of oil, 50 of water. Okay? And in fact, as the oil wells get older around the world, the proportion of water that is being produced, extracted, is increasing worldwide in proportion to the amount of oil that is extracted. Okay? So this is becoming a product that is every time, larger and larger proportionally to the oil. It's actually very difficult now to find modern information on produced water because it's become a business. And there are many consulting companies that are making a lot of money helping oil companies to get rid of produced water, because legislation throughout the world has become kind of more stricter, kind of harder on what oil companies can do with produced water. And now, basically, we don't have information. Scientists, we don't have information. You have to pay thousands of euros to consultancy companies to get any information. So, in Peru, some wells are producing in this area 98 barrels of water per 2 barrels of oil. Okay, very old wells. So one of the things we wanted to look is to look into this production water issue. Right. So the main aim of the project is to look at the exposure routes to contaminants for indigenous populations. Okay? Where they may be getting these heavy metals they have in the bloodstreams, and when the hypothesis is that it comes from the oil. Okay? And also look at what they're eating. Fish, I'm not going to talk about fish, but we're looking at fish as well, but especially as they have a subsistence economy, they hunt a lot. So we're looking into wildlife. They are allowed to hunt protected species, but as they are indigenous populations, they have permission to do what they've been doing for many, many generations. Now, one of the big challenges for us to go into this area is very remote. How to get to the area. Conditions are very changeable, very extreme, the hydrology, strong very seasonal rainfall. So when you're sampling things, you may be seeing a problem. If you may be seeing something in the dry season, which is not, or is very different in the wet season. To get things out of the area is extremely complicated. As well, you need authorization. So there's quite a range of issues that we faced. That, and what I'm going to show you is some of the approaches or some of the methodologies that we use to try to circumvent or get some data that still could be useful. That we do not apply in other type of studies because getting samples or authorizations is much simpler. So we also work with local communities that give us access to the area. You cannot get access to the area unless you have authorization from them, as well from the government. And what we've done, and I'll give you some examples, is this kind of multiple approach to study the area based on meta-analysis of grey literature, remote sensing, environmental forensics, and kind of citizen science. And I'll be showing some of the results of the 4 guys that are doing a PhD with us. The first thing I want to show you is the project that we have started more recently and is the one I'm less knowledgeable about. So I'll get it out of the way, in a way, which is the work done by Gorka, who started the thesis recently. And with work with Gorka, basically what we're looking is trying to quantify the amount of deforestation, forest disturbance, and the edge effect of all the linear structures in the area. Roads, pipelines, and seismic lines. Before any infrastructure is laid out by the oil companies, they look at for oil first, and they do surveys. They basically survey the whole of the rainforest, and in order to do these surveys, they go with helicopter, they clear the land, then they put some explosive underground, and then they go to another area, put some explosive, look at the seismic response. I mean the wavelength, the sound, how the sound travels underground, basically. And from that, they can reconstruct the structure, the geological structure, and decide if there is oil or not. So there is some impact when they do the seismic lines on the environment as well. And we've used a double approach. One is using the NDVI index, okay, basically to look at the amount of deforestation. Another one is the class light, which is kind of relatively more novel methodology. I'm told that we look at forest disturbance. And this was just to quantify, okay, the effect on the forest, basically, directly, all these structures. Gorka is now writing a paper on this, and kind of the main conclusion that we got from this work is, depending how you look at it, the impact of all this infrastructure is relatively moderate. So deforestation by the oil extraction activity is less than 2% of the area. It's just linear structures. But then when you start looking at the edge effect and how then the effect beyond kind of the immediate road could be affected land each side of the infrastructure. No, that kind of would be the area, the kind of the summary of the results. One important thing I forgot to say is we want to look at where there are impacts and when. So one thing we're trying to get is the historical evolution through time, okay? Because there's been a lot of changes in the area. The Peruvian government is now kind of trying to, it's declared the area under environmental emergency, and it's not allowing practices of the oil industry that they did allow some years ago, as we'll see. So if we look at the problem now, we have we'll get an image or a picture of what's going on, which is not representative of what has happened in the years past, okay? As we'll see. So this kind of historical, and let's say if there's going to be any lawsuits, if the local indigenous populations are going to claim for compensation, they need this historical data to back up their claims. They're saying what's happening now has nothing to do, it's much better than how the situation used to be in the past. So here you can see kind of the density of the disturbed area, okay, from the linear structure. This would be distance in meters. And Gorka and Martí basically have done this analysis comparing images, Landsat images from different periods, 1986 to 1990, 1990 to 1996, 96 to 99, and 99 to 2004. And basically, in all the images, we see this kind of edge effect. There's less disturbance as we go further away from the structure. And you could say that for the older images, okay, the disturbance probably was larger than for more recent times. Okay. And then if we take into account this disturbance, taking into account the edge effect, and then we quantify the area of the oil block that this represents, it amounts to 20% of the whole oil block. Okay. So these linear structures, although they look faint in the map, if we take into account the edge effect, could represent a disturbance of the forest equivalent to 20% of the whole oil block. So it's sizable. Okay. Yeah. Next. Right, but oil, and what we're talking is about chemicals. And if we want to look to the past and how, what's been spilled in the past, I said that these activities started decades ago. We wanted to have a way of getting information about past activities. There are different approaches that what could follow, but the one that already Martí started for his thesis was to basically get a meta-analysis, to do a meta-analysis of the data produced by governmental institutions and the oil companies themselves that, according to this legislation in Peru, they all had to produce some kind of evidence that what they were doing was polluting or not the environment. So we basically analyzed the data generated by the same oil companies, environmental assessments, and some environmental and some governmental institutions. This all amounts to close to 3,000 river water analyses, and also more importantly, they also analyze what they were spilling into the water. Okay? So the produced water outflows, the effluent analysis. There were 14 points of spillage, okay? Dumping sites. And the chemical most frequently analyzed by the oil companies and the governmental institution is chloride, but also heavy metals, lead, mercury, chromium, cadmium, also barium and arsenic, and a kind of a myriad of other analyses, which they call like total hydrocarbons, oils and fats. It's kind of sometimes difficult to know what exactly they are measuring. So we wanted to have an overall general look of this data to show if we could claim using this data, if there was a spillage which was generalized, if the impact of the oil extraction activities were widespread in the area, not just focalized to specific places where people have taken photographs, but it was a general problem in the whole oil block. And if we could see some kind of temporal change. Okay? As you can imagine, or maybe not, you can take this data in good faith. But in fact, we've published this data already, and we say in the paper, in environmental pollution, that there are lots of inconsistencies with this data, basically. Just to give an example, sometimes the measurement of the effluent, so there was a pipeline next to an infrastructure, and they were supposed to measure what's coming out of that pipeline. Okay? But when you look at the coordinates are sometimes kilometers away from the spillage point. And in fact, what they're measuring, or what they're giving you as data, is not what they are spilling, but what goes into the main river along the effluent. So they spill in a small river, and then that river goes into the Marañón River, the Pastaza River, the Corrientes River, and they're giving you as a concentration of that effluent, not what's in the pipeline, but the concentration of the water as it reaches the Corrientes River, the main river in the area. Does it make sense what I'm saying? Okay, so it's not really, so they're basically underestimating, of course, the concentration. So we have data from quite a few points along in the oil block, which is useful to say this issue about where is the problem happening. And basically that's a summary of all the data. What we look at is we compared basically the concentrations of the different chemicals upstream and downstream from a produced water disposal site. Okay? See if there was a change. And basically the highest significant increments in the concentrations were for chloride. Remember that I told you that the produced waters were basically brines, okay, salmorras. So the chloride is expected to increase massively, okay, 1,300% downstream from the upstream spillage. Also barium is one of the most abundant metals in the produced water, is also the one that changes the most. But also hexavalent chromium, cadmium, and this kind of suspended organic particles. Okay. So we basically, with this, we showed that using the data generated by the oil companies themselves and the governmental organizations, that they did change the chemistry of the waters where they were spilling the produced water. Because I should have said that produced water, they were spilling the produced water in the rivers without any controls. Okay? They basically were separating the oil from the produced waters, and then they were putting the produced water into the rivers. Now imagine that this happens in the Ebro, well, anywhere in Europe. No? This would not be acceptable. And now we are working on the historical perspective. The data gets noisier, but we're looking how this has changed through time, how the concentrations have changed through time. And we're basically picking up is the change as Peru basically accepted that they had to control the oil companies and they had to oblige them to stop spilling the produced water into the rivers. Basically, we can see this change by looking at this meta-analysis data. Of course, both in the produced water, this is in one of the Corrientes River, in one of the main rivers in the area, the Corrientes, and we compare it to the Tigre, another one of the main rivers, the Tigre and the Corrientes River. And we look at the, in black, you can see the flux of chloride of produced water, and in orange is the concentration downstream of the spillage point. So you can see that as the flux of chloride spilled decreased due to the legislation, because produced water was released into the environment without treatment until 2005. In 2009, they started really controlling the spillage, and you basically, you don't see it very well, but you basically see this change around this area. Okay, so in both rivers, we can show how they change basically. But that's useful as the legislation came into force. So with this, we can show how important was the problem before, and if now we have an issue that has forced an environmental problem that has forced the Peruvian government to implement an emergency alert, and this was implemented in 2013. Okay, so imagine how could have been the situation prior to 2005. Okay, the problem must have been much basically important. So basically now we're going into an area in what they're spilling is, we'll show is clearly considerable, but prior to 2005 it was even larger. Okay, the oil boom was in the 1970s. Remember, this is the headwaters of the Amazon. We can also show these kind of changes in concentration of heavy metals with lead and other metals. We can also show that there was a change in concentration in the river waters. These are the headwaters of the Amazon. There was a paper published in 2014 that, following a completely different approach, looking at hydrological monitoring stations set up by French agencies in different parts of this area, of this catchment. And they've been measuring cations and anions concentration. They also been measuring the concentration of these anions and cations further downstream in the Amazon. They don't have a large time series, but they have data from 2006 to 2010. And they basically pick up this change as well in concentration in the Marañón River. This would be this data here. And basically one of the main conclusions of this paper is that they also compare this change with data in Óbidos in Brazil. And basically they're saying that the salinity of the Amazon in Óbidos, which is hundreds of kilometers downstream, changed by 20%. So basically what was spilled in this area changed by 20% the concentration of the Amazon on salts. The Amazon is quite big. Okay. I'm running out of time and I still have a lot of data to show you. What we've been trying now to see, and we're going to finish off, is what's been spilled in the environment, how could have got into into humans, basically, into wildlife and into humans. Okay. For that, we've been characterizing oil pollution in soils and sediments of the area, and we've been focusing in an area specifically, or we've been studying an area which are the salt licks. Salt licks, high hotspots for hunters. They are also hotspots for the concentration of wildlife. You know that the wildlife in the Amazon is, or the Amazon is in general nutrient deficient. I think some people know a lot about nutrients in the Amazon. So wildlife in the area have a problem with accessing or getting enough nutrients. And there are these hotspots, it's salt licks, in which a higher percentage or higher proportion of wildlife flocks goes and basically feeds on soil. 30% of the diet of many of the animals there, mammals, is soil. So there is the issue of geophagy. And the people in the area, the local indigenous populations, have been claiming that in areas where there's been oil spills on land, they become anthropogenic salt licks. For some reason, wildlife has been flocking and they've been finding them feeding in areas where the soil is polluted. Produced waters are rich in minerals. They are rich in salts. Okay? So that could be one of the reasons. We found, these are photographs of feces, which are all polluted. And we've been trying to see how this pollution in the soil on which these animals are feeding could be transferred into the animals. So we've done a relatively extensive program of analysis of sediment, soils and waters, soils and sediments, which is still ongoing. I'll just go quickly to some of there would be an image of one of the pipes, for instance. You can see a pipe that would close and open, and you can see here some hydrocarbons in the soil. Okay. One of the things we did was to set up a camera trap program to have video evidence of animals feeding in these areas. And this is the thesis of Marc Artreau here, which is deposited the thesis today, in fact. And kind of studied in more detail 15 anthropogenic salt licks and 3 natural salt licks. The identification of the salt licks has been given to us by local hunters, because hunters, you know, they go to these places and they find animals. So, and these are animals that it's not that they don't care, but they want to eat basically. And even if they know that the animal is polluted, they basically scrub it off and eat it. In order to help Mar, and also helped by Vicky Reyes to process all the videos that they've generated, they set up a website where you can find these lots of these videos, and we basically the identification of the different species in these areas has been done through this kind of citizen science project. If you put Amazon oil and Marc Artreau, you'll get into this website. And there's a myriad of species that they have identified, recorded visiting these oil polluted sites, from different types of deers, birds. Some more visit these areas more frequent than others, right? So it's not just restricted to some specific species, but it's quite a number of them. And then we've compared what we find in these areas, in this oil block, with what local hunters have got into control areas, or natural protected areas where there is no oil activity, or not known oil activity. And some of the work that I'm going to finish off showing is about heavy metals, basically lead. Okay? The local hunters are the ones that gave us the Basically liver and some other entrails from the animals. And they monitored and they gave us quite a lot of information about different species. As you can imagine, transport these samples to here has been quite complicated, but eventually we got them here and analyzed 400 samples from 32 species. Okay, so it's quite comprehensive. Look at range of metals. This is the first data. Oil concentration in red, control area in green. In general terms, the concentration of heavy metals in the livers, in the oil blocks, is higher than in the control areas, okay? Except for lead, okay? And then is the wonder about, should we show that? Maybe it was a mistake, let's forget about it, okay? Look at barium. Look, barium is the most abundant metal in produced waters. It's also very abundant in livers, okay? So what we did then to work out where this lead may be coming from, we did lead isotopes. We did it here in the Autonoma with Ignazi in the SAC, and we basically look at stable lead isotopes, okay? Not radioactive, stable lead isotopes. The ratios of 207, 206, 208 to 206, basically. It's a known way of tracking provenance. Control livers, okay? Oil samples, okay? They flock in different areas. We have a bit more data, but the lead from livers in animals hunted in the oil blocks. We were quite surprised to see that they were basically in the two different river catchments, the Pistachio and Corrientes. They plotted on top of the control areas and also with some of the oil samples. Okay. So what's going on here? Lead pellets. We realized basically what we're seeing here. These people here didn't used to hunt with guns. They used to hunt with cerbatanas, you know. Not that long ago, but then a few decades ago, guns were introduced and they started hunting with shotgun, with lead shotgun, basically. And lead pollution is widespread anywhere in the planet, right? Hunting with lead is a problem worldwide. It's forbidden in Europe hunting with lead pellets in wetlands. The Amazon is a big wetland, basically, right? So why shouldn't it be a problem? Lead pollution from hunting in the Amazon when it's a problem everywhere, basically. So what we've identified without looking for it is a problem of lead hunting pollution, basically. Okay. So basically lead could be coming. We also look at natural salt licks, looking at the soil, okay? From anthropic soil licks, looking at other sources of lead. Without realizing we've basically we identified hunting activities is probably, and they eat a lot of game, basically have a subsistence economy. So what we're arguing is the high blood level, the high lead in blood, the high levels of lead in blood that they have in the area, an important part of it is probably coming from hunting, okay? And another part could come as well from oil activities, okay? From the produced water spillage, but hunting as well. So to conclude, environmental impacts are widespread in the oil block from the extraction activities. The vegetation from the remote sensing, river water and soils. Past impacts are probably larger than what we see at present, and they are likely to have been transported downstream in the Amazon, so they're just not focused in this area. We also show through the camera trap program that wildlife in the oil block feeds in polluted soils. In some places they even seem to favor these areas. Okay, and in the livers of these animals there are high concentrations of lead. And these concentrations, I forgot to say, are very high. Okay, equivalent to what we have here in industrialized countries, and much higher, of course, than the permissible limits. And we identify different sources of this lead. Hunting is one of them, and probably one of the most important ones. So we need to evaluate the risk to health dependent on subsistence hunting for these local populations. And this, we argue, is not just a problem probably just here. It's probably a general problem in the Amazon and in other areas of the world. We found one paper in Canada for indigenous populations in Canada also that have problems with lead pollution. But probably many places throughout the world are still hunting. Depending on subsistence hunting, they probably have a lead contamination problem. So is the Amazon at the end of the anthropogenic impact continuum? This is, one of the areas that seem to be less impacted in the Amazon, but clearly there's still other areas with any industrial activities. But when we're talking about the Amazon in general, we should be careful because we show that, unfortunately, in the headwaters of the Amazon, there are these activities that have not been reported before, and that impact the whole catchment of the Amazon. And just to give you an idea of proportion of the size of the issue and how we should, I think, encourage more and more people to look into the impact of these activities on land. Most people working in oil pollution, we worked in the oceans. Every time there is an oil spill, it's very visual, it has a massive visual impact. Sizes of oil disaster, 2010, millions of barrels of oil. Okay? The largest oil spills, Exxon Valdez, 9 million barrels of oil. It's true, it's just, perturbation. It's just very briefly, you spill 9 barrels of oil into a very small area, and it has a very important impact. The cumulative spillage of produced water in this area that I've been talking about is 7,094 million of barrels. Okay, so compare 7,000 millions of barrels to 9. Okay, so it's true that it has happened over several decades. It's true that it used to be worse before 2005, but we're talking about the magnitude of something spilled in one of the most biodiverse, remote environments of the world of an incredible proportion. It's 11 times higher, what's been spilled here, than the annual produced water spillage in the USA, which is the 4th oil producer in the world. Peru is a minor oil producer in the world. Okay? It's a minor oil producer. So this is 11 times higher. And maybe you have heard about the lawsuits in Ecuador. There was an Ecuadorian government, local indigenous populations there with other communities sued Texaco Chevron, and they're still going on the appeals and the lawsuits. But basically, what happened in Ecuador is much smaller than what happened in Peru. Okay, what happened in Peru is 16 times bigger than what had happened in Ecuador. Okay? And we focus only in this area, right? And I've said before that, oil reserves overlay tropical rainforests worldwide. So it's an issue to know what has happened. So every time you see people talking about oil, I'm now asking everybody about the produced water. What happened with the produced waters worldwide? Nobody talks about produced waters worldwide. And I have colleagues from my PhD times work now with big oil companies, and Kazakhstan, Russia. They just dump them. Okay, so there's probably dumping of produced waters in the Arctic rivers, okay, in regions of Africa, And who knows what happens in Nigeria, what happens in Indonesia, what happens anywhere else. Okay? So ask, the only people that are actually talking about produced waters and what to do with them are the Americans. In the oil sea, in the platforms in the sea, they spill them in the water, in the sea. It gets diluted. Now the European legislation forces them to do a treatment to go below a certain concentration level. But basically in the ocean, they just throw them into the sea. Okay? And sorry for this negative talk, but that's what we've been doing. I wanted to talk about fires, you know, much faster. Anyway, thank you, that's it.
Time for question?
Tony? Yeah. By using LDBI, do you think that there may be an underestimation of the impact by being saturated quickly? Of the vegetation in the first work, what do you think?
I don't know. To be honest, it's one of the issues I have less of a knowledge about that. I'm learning about remote sensing as I go along with Gorka and Martí. So any comments I can pass on to them will be really useful.
Yeah, Gorka was here, I think, yeah.
Yeah, Gorka was here. Gorka has worked in quite a few places around the ICTA and CREAF, and
So
yeah.
greetings to him from there.
Yeah.
But apart from that, the other thing that one wonders is, apart from other metals like arsenic, you didn't mention much.
No, because we haven't had time yet to process all the data. This is just the tip of the iceberg of the data. We went into lead and cadmium we should look at because it's what was reported in the bloodstream of people, basically. And the people in the area were very concerned about where the lead was coming from, and they want us to show them that the oil companies were responsible for the lead in the bloodstream. They were not too happy when we told them that they were only partly responsible for it.
And my last question is, you are expecting these organic pollutants. So can you tell us something about them?
We're processing.
Focus on metals, but
Yeah.
wonders about the organic pollutants.
I agree. We are processing them now. Núria Moraleda is now analyzing about 40 samples of soils for PAHs. We've basically shown that there are pollution, that in many of these soils we look at the typical hydrocarbons to show that there is oil pollution, stains and hopanes, basically. And we show that we basically, in these areas that I showed, that I mentioned that they had oil pollution, we only say it in the areas where we measured the hydrocarbons in the soils. Okay, so or in the areas that we say there are control, we also have shown that there are no hydrocarbons. Okay, looking at sterins and hopanes. So we've done a few samples in comparison to the size of the area. So basically to show with her data. And now the next thing we are doing is to look at polyaromatic hydrocarbons. Because of the toxicity, the potential toxicity of these compounds. But it gets complicated by the fact that in tropical areas there are also natural sources of polyaromatic hydrocarbons. For instance, pyrene comes from fungus. Ant nests produce naphthalene. So there are things that we have to be careful with. We also, there is an initiative called Public Labs. It's an American initiative. It's kind of an NGO that basically produced instruments to make measurements at a very, very low cost. So with part of the thesis of Raúl Yusta is to use this instrument, which is basically an spectropluorometer developed by Public Labs, which is composed of a CD disc, okay, CD disc. You know, one of the things that sometimes people use to varnish their fingernails, okay? So a varnish flask that we put, that we use to extract the hydrocarbon from the sample. We use baby bottom oil, you know, the thing that put to, it's a lubricant, it's just basically waxes. So using very simple products and a mobile. So they basically put this kind of instrumentation, which is very simple, made by products that are very easy to get. It costs $100. Now they price the price to $150, and we can use it to make measurements in the field that are still valid to show that there are polyaromatic hydrocarbons. So basically, Raul has been testing it in the field, and then we've done measurements in the lab using a spectropluorometer, a proper, 15,000 euro spectropluorometer, and a GCMS, 60,000 euro GCMS to validate this data. And basically, this technology, we can measure the concentration of pyrene in the samples. There's a problem that pyrene is in oil, but it's also a natural product. So there's a bit of uncertainty, but yeah, it's quite spread. I mean, anywhere there is oil, there's pollution anywhere. And a third thing we'll be doing is forensic, environmental forensics, which is basically used the different composition, the abundance of different compounds, also the isotopic, stable carbon and hydrogen stable isotope composition, to basically to track the sources of the oil spilled, right? Because oil companies may say, the oil companies have been changing through time, and they say now, well, that spillage, I didn't do it. It happened 10 years ago, and I'm not responsible for it. It was responsible the other company that used to manage the block. So we are trying to see how we can use this chemical data to basically work out where the spill comes from exactly, and the age of the spill. Okay, because the spills age with time, they get oxidized, and then according to the rate of oxidation and change of the composition of the spill, maybe we can track as well, work out the age of the spill. So we could have worked for a few years. At the end of this data, if anybody eventually wants to sue or kind of find responsible for this, this data could help. Anyway.
Do you have an hypothesis on why is the lead concentration so much higher in the control area? Because maybe I missed it, but of course the lead pellet, it makes a lot of sense, but still there was a huge difference.
It is.
Hunting with lead was a different time in different places? Or?
No, we don't understand the concentrations. It's something that puzzled us. Why is so high there? In fact, just working out exactly why how the lead gets into the liver and then is transferred from hunting, it's a bit complicated. Basically when people hunt, the pellets break down, the lead is turned into an aerosol. So lots of particles, microscopic particles spread around as an aerosol. And also as the pellet goes into the tissue, apparently it contaminates a huge area around the path. Right? And then we go along and we take a part of the liver, and from that we find the concentration. These are control areas, the hunters are different. There are lots of issues that we do not control to.
The species also probably are different.
Yeah, there are some differences. Mark Arturo is looking into the species different. There are some differences in the species as well. Yeah, probably related to trophic chain. We found very high lead levels in gators, reptiles, which is kind of strange. There are lots of things that we cannot explain. So have lots of hypotheses, and you're welcome to give us more. But it's one of the things that we're puzzled about. Yeah, should have said when we analyze fish, for instance, haven't showed any data on fish. Fish has no lead in them. Fish in waters has no lead, but they have mercury, which is also a common problem, a common occurrence throughout the Amazon. Yeah. So what we find in lead, but lead concentrations are very low, not especially high.
Maybe they found one species more in the control area. Did you see the difference?
With the fish?
The species that they found in the oil.
Yeah, there are big differences in the values are higher in the control areas. The species are not the same. So we've been trying to show that there is also lead from hunting, from pellets in the soils, and maybe the concentrations are higher in certain areas than others. Hunters go where there is game. And nowadays they can travel larger distances than they used to in the past. So one hypothesis is that in these protected areas, maybe there is more game. So maybe there is more hunting pressure. But we don't know yet.
If I understood well, there was a lot of contamination from the produced water until 2005 when the Peruvian government put some measures. And then the companies had to clean the produced water, or what?
Well, they had to start doing something about not spilling them, basically, which is what the oil companies have to do worldwide. There's now legislation everywhere.
They have to do pipelines to...
No, they reinject. They claim to reinject most of it. So reinjection already happens. They do it already because it helps to increase the yield of oil from the well. So they inject the water to get more oil out. And then they put it in kind of pools, and then it separates by density, and then they get the water and they reinject it. Nowadays they are claiming that they have reinjected everything they produce. This is fracking at large scale, basically. Okay, so you can imagine. The oil comes from several kilometers below ground. To inject water at that depth is extremely expensive. So it's always a cost-benefit analysis. So they probably cannot inject it at the same depth that it came from. It probably goes at a shallower depth, and it probably goes sideways. And there are places that people claim that they see surgences of salt water, new wells coming out of salt water in places. So that's something we want to try to see if we can establish. That probably this reinjection is basically spreading the produced waters to many other places, right? So rather than just spilling in 14 places in a concentrated manner, it just goes below ground, it goes to many other places. And then, we don't see the effect in the concentrations in the rivers. But at the end of the day, Okay. Thank you.
Thank you. Yeah.